Welcome back to Math 104. Recall the model of a stock price, which either increases by $1 or decreases by $1 every day with equal likelihood. Find the probability that after 30 days, the net change in the price of this stock is exactly $10. That could be a net increase of $10 or a net decrease of $10. What we really need to find here is the probability of a net increase of $10 plus the probability of a net decrease of $10. How could that possibly happen? A net increase of $10. If you think about it, over 30 days, the only way for the net change to be exactly $10 is if there are 20 ups and 10 downs. If there were any different number of ups and downs, the difference would not come out to exactly positive $10. We need to add to that the probability of 10 ups and 20 downs, because that's the only way to get a net loss of $10. That also counts towards the event of a net change of exactly $10. We know how to compute these probabilities. These are 30 choose 20 over 2 to the 30th, plus 30 choose 10 over 2 to the 30th. Now these numerators are actually going to be equal, and so the probabilities are going to be equal. That makes sense here because of the symmetry of row 30 of Pascal's triangle. 20 ups, 10 downs, or 20 downs, 10 ups, those should have the same probability as one another. And now the whole point of asking this question at the current stage in the course is that we have a formula that makes it practical to compute these probabilities. Let's go to the spreadsheet and see what it tells us. Here I've used the function mentioned in the last video, equals combin 30, 20 over 2 to the 30th. So that's computing the probability of 20 ups and 10 downs. Sure enough, we get exactly the same probability when we compute 30 choose 10 over 2 to the 30th. That's the probability of 10 ups and 20 downs. What we really need is the sum of these two. That is approximately 0.05596. Let's record that over here, that the probability that after 30 days the net change in the price is exactly $10 is approximately 0.05596. We introduce a new topic, odds and probability. Statements about odds express the same information as statements about probability, but they use a different language and are based on a different perspective. By tradition, odds are often used instead of probabilities when talking about sporting events and the likelihood of one team winning instead of another team winning. So let's plunge in with an example. Fans are already thinking about the next Rutgers-Ohio State football game. Let us suppose that Rutgers has a 40% chance of winning. Yes, that's a bit optimistic from Rutgers' point of view, but let's go with it. Describe an ideal dataset for the experiment of seeing which team wins, and represent it in a strip diagram. So this is what I mean by a strip diagram. Depending on where you went to school, you may have seen strip diagrams quite a bit in your math classes. So I'm going to draw this rectangular array of boxes. Each box counts the same as every other box in representing a certain fraction of the time that Rutgers plays Ohio State. Since Rutgers has a 40% chance of winning, I'm going to mark 40% of the boxes, that is to say 2 of them, with RU, and I'm going to mark the rest with OSU for Ohio State. This is a certain visual way of representing what will tend to occur in the long run if this 40% statement is really true. This representation is really the same thing as writing out an ideal data set of winners. There are five winners in an ideal data set. 2 of them are Rutgers and 3 are Ohio State. Notice that 40% equals the fraction 2/5, and you can think of a fraction as a part-to-whole ratio. 2 represents the part, and 5 represents the whole. Now, we can express exactly the same information as a part-to-part ratio of the number of Rutgers wins to the number of Ohio State wins, namely 2 for Rutgers to 3 for Ohio State. The terminology here is we say that there are 3-2 odds against Rutgers winning, or 3-2 odds in favor of Ohio State winning. The way to think of this is, for every 3 games Ohio State wins, there are 2 games Rutgers wins. It is typical when you talk about odds to put the larger number first, not absolutely necessary, but typical, and then you can express the statement either from Rutgers' point of view, that these 3-2 odds are against Rutgers, that is to say, it is more likely than not that Rutgers will lose, or we can express it from Ohio State's point of view, that the 3-2 odds are in favor of Ohio State. It is more likely than not that Ohio State will win. Let's look at some other examples. A pair of dice are rolled. Let's assume the dice are fair. One is blue and the other is red. Consider the following events. E is the event that the blue die shows a 3. F is the event that the sum on the dice is at least 9. Let's first look at E. What are the odds in favor of E? Before we do anything else, let us draw a strip diagram. E pertains only to the blue die, so what should an ideal data set look like? It should have 6 die rolls in it, 6 outcomes in it. We can label this by 1, 2, 3, 4, 5, 6, but we really just want to keep track of how many times does E occur, how many times does E not occur. So in the third box here, I'm going to write E, and in the rest of the boxes, I'm going to write E complement. For every 1 time that E does occur, there are 1, 2, 3, 4, 5 times that E does not occur. Or for every 1 time E occurs, there are 5 times E complement occurs. So the odds in favor of E are 1 to 5. For every 1 time that E does occur, there are 5 times E doesn't. And so the odds against E are 5 to 1. If you know the odds in favor of an event, then the odds against that event are just the same numbers reversed. Now let's turn our attention to the event F, that the sum is at least 9. Now this event pertains to both dice, so when we attempt to draw a strip diagram, we can't draw the same one with just 6 boxes in it. We really need to think about all 36 equally likely outcomes of this experiment, and that's true whether we're thinking about probability of F, or odds in favor of F, or odds against F. So to carry this out, to understand the odds in favor of F, or against F, drawing the diagram this way is useful. We've done this sort of thing before, just without the grid. We need 36 boxes, and 10 of them are already filled in with the outcomes that are in the event F. Stare at this a little bit, and think, before going on to the next video, what are the odds in favor of F? And what are the odds against F?